Hey, welcome to the Flipped Classroom for AP Calculus. This is our first session for the new semester, and we're starting Chapter 3, specifically Section 3-1. This would be Session 21, and our topic today is extreme value of functions. There are basically two types of extreme values when it comes to function. Absolute, also known as global, and relative, also known as local extreme values. We'll begin our discussion with the absolute or global extreme value. Absolute or global extreme values are fairly simple. The easiest way to think of these is, let's just say you have a very nice house and you think your house is the best house. In fact, you know it's the best house on your street, but you're not sure it's the best house in the neighborhood. An absolute or extreme value or a global extreme value would be the best house in the neighborhood. A local or relative extreme value would be the best house on your street. Do you understand? So, mathematically, let's look at a function with a domain D. And we'll say that C is some value in the domain. Remember, domain is what the X values, or as they call it in algebra, input values can be. Then f of c would be an absolute maximum for f of x if and only if f of c is greater than or equal to all f of x values. Similarly, f of c would be an absolute minimum if and only if f of c is less than or equal to all f of x values. Let's look at a simple function, parabola, y equals x squared. Normally, its domain would be all real numbers or negative infinity to infinity. Graph it, and you could see that there is an absolute minimum at 0, 0. There is no maximum because there are no endpoints here. Okay? Let's look at the same function, but this time we're going to take the domain and restrict it to the open interval 0, 2. I said open interval where the endpoints are not included. There are no absolute extrema in this case, because if you look at that, you cannot find the least value or greatest value for the function. You might say it's at x equals 0 or x equals 2, but those endpoints aren't included. So how close do you want to pick your value to 0? Because I can always find one that's in between 0 and your value that you pick. However, with a small change, namely making the interval a closed interval, now we have an absolute minimum at 0, 0 and at 2, 4, because now those endpoints are included and the function values at 0 would be 0 and the function value at 2 would be 4. Okay? And they would be absolute extrema. Here's kind of an important yet simple little theorem. It says that if f of x is continuous, remember what continuous means, the limit exists, the function is defined for all points in the domain, and the limit is the function value. So in this case, if it's continuous on a closed interval, I, then there is an absolute minimum and an absolute maximum in that interval I. But it needs to be a closed interval. Local or relative extreme values. This is like the nicest house on your street. F of c is a local maximum if and only if f of x is less than or equal to f of c for all x in some open interval. Okay? We're not including endpoints here. F of c is a local minimum if and only if f of x is greater than or equal to f of c for all x in some open interval. So how do we find these extreme values? Well, if f of x has a local min or max at an interior point, c, of its domain, and the derivative exists at that point, c, then f prime of c will be 0. This means that there's a horizontal tangent at c. Think about it. What we're really talking about here on the graph is a hill, which has a horizontal tangent, or a valley, okay? The high point and the low point. Both those would have horizontal tangents. Any value c where f prime of c is 0 or undefined is called a critical point and maybe, doesn't have to be, maybe an extreme value. So, the only place a function can have extrema are 1. Interior points where f prime of x equals 0. interior points where f prime of x is undefined. Those are called critical numbers for both those cases. Or the endpoints of the domain of f of x as long as our interval is closed. Again, how do we find extreme values? Let's try one. Let's say that f of x equals 10x times the quantity 2 minus the natural log of x on the closed interval 1 comma e squared. Step 1, check endpoints. We do that, we find that f of 1 equals 10 times quantity 2 minus the natural log of 1, which is a value of 20. F of e squared is 10 times e squared times quantity 2 minus natural log of e squared, and that simplifies out in the wash to be 0. Keep those numbers in mind. Second step, let's take the derivative of this function and set it equal to 0. So f prime of x would be, you have to use product rule here, 10x times negative 1 over x plus quantity 2 minus natural log of x times 10. And that simplifies out and to negative 10 plus quantity 2 minus natural log of x times 10. Set that equal to 0, solve it, and when I solve it, I wind up with the natural log of x equals 1, which happens when x equals e. So x equals e would be a critical number, and f of e, the function value, would be 10 times e, which is about 27. Okay, so now I've made a table here showing some values. Our endpoints of this closed interval. First I have 1. Remember the function value there was 20. It is an endpoint. Then I have e, which was our critical number. The function value f of e was about 27, and e squared is the other side of the closed interval. Its function value was 0, and it was an endpoint. Okay? You can look at this and see that the smallest number, 0, is an absolute minimum, and the biggest number, about 27, would be an absolute max. So we would say an absolute max occurs at e, comma, 27, and an absolute min occurs at e squared, comma, 0. Okay? Here's another one. Let's say f of x equals 1 over the square root of the quantity 4 minus x squared. The domain of this function is open interval negative 2, 2. There are no endpoints. And we can't get any smaller than negative 2 or any bigger than 2 because then we're dividing, taking the square root of a negative number. Graph it. It would seem to be an absolute minimum. Let's check it out. Take the derivative, okay? Got to use chain rule on this, and when you take the derivative of this, it comes out to be x over the quantity 4 minus x squared raised to the 3/2 power. This derivative is undefined at x equals 2 or negative 2. So you might think, well, that's a critical number, right? Those 2 points are not in the domain. Go look at the top of the slide. Okay, so we don't have to worry about them. So the only other thing I'd have to check is, hey, is there any value of x that will make that derivative 0? I'm glad you asked, because yes, there is. X equals 0 makes that fraction equal to 0. So x equals 0 would be a critical number and the only choice for a possible minimum or maximum. The function value at x equals 0 is 1/2, and from the graph it must be an absolute minimum. We know this is a minimum also by looking at the original function, which is 1 over the square root of 4 minus x squared. As x moves away from 0 in either direction towards negative 2 or 2, f of x gets bigger. You can check this out by looking at your table of values on your calculator. Therefore, x equals 0 must yield the minimum function value of 1/2. Having a critical number does not guarantee extrema. I'll say it again. Having a critical number where f prime of x equals 0 or it's undefined does not guarantee extrema. Let's look at the function y equals x cubed. Domain, negative infinity to infinity. The derivative is 3x squared. This equals 0 when x equals 0. But graphing this function shows that x equals 0 is neither a minimum or a maximum. So don't think just because you have a critical number you're guaranteed a minimum or a maximum. That would also work if you just want to play with it for f of x equals x to the 1/3. Same story. What I'd like you to do for your practice problems, pages 251 to 252, numbers 1 through 44. I expect you to have watched this video, and when we come back from break, first thing, we're going to have a little quiz on Edmodo to see who's watched the video and who hasn't. You may use your notes if you're inclined to take them. Thank you, and enjoy your break, and have a great holiday. See you in a couple weeks. Bye.